Ladies and gentlemen, today we are starting a new lab on natural selection through evolution. You do have a lab handout packet. If you wait till the end, I will read through the whole thing with you. But first, let's do the short version of what I'm expecting. All right. We are going to see the evolution of a species through natural selection. So what you need to remember is, one, evolution is not about an animal changing. All right. Individual animals do not evolve, right? This isn't Pokemon. In the real world, it's your DNA that evolves, and not yours, but everyone's. The entire population is going to evolve. That's how evolution works, guys. Generation to generation to generation. You are going to pair up with somebody, maybe, and have kids. And so is everyone else. They're all going to have kids. So the next generation, are their genes different than your generation's? And then those kids will grow up and they'll all have kids. And then those kids will have DNA. And will their collective DNA be different than the previous, which is different than yours? Is it changing? If it is, that's evolution. What I mean by change is how often certain traits will show up. Take a look here. This is the example we're going to be using, guys. Rabbits. In this lab, we are going to be breeding bunnies. Now, there's a certain species of English rabbit that has a recessive trait that they are born without fur. Now, here's the problem. England is very cold. So the furless bunnies tend not to survive into adulthood. The furless bunnies don't tend to reproduce. So if this is not reproducing, what's going to happen? Well, that's what we're going to find out. That's today's lab. So how are we going to do this? First off, we need genetics. We need genes to pass on. We're not going to actually breed bunnies for a whole bunch of generations to find out. We don't have time for that. So we're going to make do with whatever you have lying around. I am using paper, little paper balls. The blue for me is going to represent the dominant allele, or in this case, the big F. And the pink is going to represent the little f. You can use whatever you want lying around. In a normal class setting, I would bring like dried beans, red beans and white beans. You can use whatever you have. Use pocket change. I don't care, as long as it feels the same. That's the key. It feels the same, not looks, because you're not going to be looking. So, like I said, I'm using paper balls, blue and pink. So just so I don't forget, I'm going to make a change here. My dominant alleles are the blue one. And my recessive alleles are pink. That's just what I am doing. You do what works for you, what you have available at home. Now, what you are going to be is the adults. You are the adult rabbits. You are going to be the entire species. This is going to be the rabbit warren. That's the hole in the ground where they live. You and all the other adult bunnies, well, adults or rabbits, are going to go into the warren, and you are going to spread your genetics. That means having sex. Yes, guys, you're going to pretend that these rabbits are having sex, and they're going to be spreading their genes all over the warren. The dominants, got some recessives, and you are going to have 50 dominants and 50 recessives. Yes, 50, guys. So whatever you're going to use, you need 50 of each. 50 dominants, 50 recessives. And you are going to shake up whatever receptacle you chose to put this in. But remember, you cannot see. Don't use like any clear glass or anything. You don't want to be able to look in here and see what's happening. And because reproduction is random, you don't know which gene the parents are going to pass on. You are not going to look. And this is why they have to feel the same. And honestly, I'm not looking into the hat, and I'm going to pick 2. And I picked 2 recessive alleles. Notice I got, zooming in here, containers marked off. So I'm going to put my 2 recessives in here. And what did I say, guys? Unfortunately, the recessive ones don't grow fur, so they don't live too long, right? So Sad news for these guys that are just, that rabbit that was just born. That's a tombstone. That poor rabbit has died. So that is going to be the graveyard for the recessive ones. Now these guys don't get graveyards, right? Because they're fine. They're going to have dominant alleles. So now we still have more rabbits to be born. And you're going to keep doing this, not looking. And I got, oh, sad, another one. Notice I get 2 alleles. Remember, everybody gets 2 alleles for every trait. All right, this is not 2 bunnies. This is 1 bunny with 2 alleles, one from mom, one from dad. So mom gave a recessive, dad gave a recessive, and unfortunately that means this bunny died because it doesn't have fur. All right, I'm gonna pick again. And I got, ooh, a dominant and a recessive. What do we know about dominance, guys? Dominant always shows. So dominant and recessive, dominant trait wins. That rabbit has fur. It gets to live another day. I'm going to put it in my heterozygous cup, big F, little f. And yes, I'm going to cheat this time because I want to just get the other one out of the way. I dropped it. 2 dominant alleles, 2 big Fs. So I'm going to go here, and I'm going to keep doing this until my hat is empty. You're going to keep doing this until you did all 50 dominants, all 50 recessives. They're all done, right? But here's the thing. These poor guys are dead. We're going to have to give them a funeral. And now, all we have left alive are the ones that ended up in these cups, right? Because the dominant alleles gave them fur, so they got to be warm and survive the cold winters. So these guys are going to go back into your gene pool. But wait, we need to count them out. This is your first generation. This is the chart that I gave you guys. It should be on Google Classroom right now. But where are you going to put your information? Now, right now, it looks kind of weird. Actually, let me get rid of that. There you go. All of these random things right here, that is math that I put in for you. In a normal classroom setting, I would have you working in partners doing this, and you were doing all this math together. Since you were working by yourself, I went a little easy and I did the math for you. So as I click on it, it appears right here. Do not mess with this. Do not mess with that. Do not mess with this over here. Do not change my math or your whole thing is messed up. What you are going to do is figure out how many bunnies there are. Remember, 2 alleles equals 1 bunny. So if you only got 2 big Fs, you pulled out 2 blue ones, that's 1 rabbit, right? Because 1 rabbit has 2 alleles. You're pulling out the alleles. If you did that twice, you get 2 sets of 2, you got 4 blue alleles, then that is 2 rabbits. Nice and easy, right? How many? Actually, I only picked out one of these guys, and then I picked out one of these heterozygous big F lips. You are going to be doing a lot more than I did. You should have a lot more than that. And then you're going to count how many alleles. These guys had 2 blue alleles. Or sorry, we'll call them big F. The blues are big Fs. These guys had 2 big F alleles. This guy had 1 big F allele. So that's 2 plus 1 is 3. There are 3 big F alleles. And notice my math started changing now. Total number of alleles, 3. How many little f alleles? Well, the little f ones are dead, so don't fill this in. And how many little f survived in the heterozygous? 1. Because this rabbit had 2 alleles. 1 is a big F, went in this column. 1's a little f, went into this column. So now there are 4 total alleles. Look over here, gene frequency, 0.75 for big F. That means 75% of the time we came across big F alleles. 25% of the time, 0.25, we came across a little f allele. That is the math we are looking for, and this is what's happening on my chart that will automatically graph for you. Again, made it easy. You're not graphing it. I'm graphing it for you. Your numbers are going to be way bigger than my numbers because you are going to do all of the rabbits. 50 big F alleles, 50 little F alleles that you are starting with. You pull out your first generation out of that. And once you get rid of the ones that died, what is left over? Then you are going to take all of your alleles and put them back in the warren. Why? Because those rabbits that survived grew up. And now they're going to reproduce. And now they're going to start a new generation. And then you're going to do this again for generation 2. Just start pulling. Don't look. I looked. I know. Heterozygous, big F, little f, and put it in the correct cup. And you keep doing that until you fill out the entire graph for all 10 generations. Yes, 10 generations, which is why I'm giving you all this time. Multiple days to work on this, all right? All right. If you have any questions, comments, or concerns, feel free to ask. If you want me to read all the directions to you, stick around. I will begin that now.